Are you looking for a new project to add to your developer portfolio? You're in luck because in this video, I will break down Taskmaster, a Pomodoro timer and task manager app I built with Flutter and Firebase. Not only will you gain valuable insights into these technologies, but you'll also walk away with the knowledge to create a simple project that demonstrates your skills and boosts your portfolio. This app can be broken down into two different concepts that you need to understand: the BLoC pattern and real-time updates with Firestore. So what is the BLoC pattern? The BLoC pattern is an event-based pattern used to help developers manage state in their Flutter apps. BLoC stands for Business Logic Component. The main idea of BLoC is to separate the business logic from the UI. This means the UI can react to a change in state rather than create the change in state. The BLoC pattern is based on streams in Dart, where a stream is a continuous flow of data. There are two different streams that we need to concern ourselves with: the event stream and the state stream. Events can be added to the event stream to then be handled by the BLoC handler functions, and states can be added to the state stream for the UI to react to. You can envision a front-end app as a continuous flow of events and states. An event could be a physical action like a button press, or it could be something that gets triggered when a new page loads. The last note to mention before diving into an example is the different kinds of files that make up a BLoC. We have the UI code, which will be the page or view file. This is the file that will react to the state changes. Then three files comprise the actual BLoC. We have the event file, state file, and BLoC file. The event and state files define the events and states respectively. The BLoC is where the events are handled and states are emitted. The first example we are going to dive into will be the login page and login block. When using the BLoC package, we have access to a few different widgets to help us in implementing the pattern. In this video, I will be focusing on three of them. The first will be BLoC Provider. This widget is responsible for providing the BLoC to be used to handle events later in your app. You can see here we created the login block with the required dependencies in the create callback exposed to us in the constructor. Now that the login block is provided, we can add events to the event stream and listen to state changes in the UI. Speaking of listening to state changes, the next two widgets are different methods of listening to states emitted by the BLoC. The first widget for listening to the state is the BLoC listener. Scrolling down in the code, we can see this widget gives us access to a listener callback that has the context and the state. However, this is a void function and does not return anything. This widget is purely to listen to state changes. Depending on the state, you could show toast as I am here or navigate to a new page. The BLoC listener is also completely optional, so if you do not feel the need to listen to state changes without changing the UI, the child of the BLoC provider that we showed above could be the BLoC builder. The BLoC builder is where the UI reacts to the state changes from the BLoC. You will notice that the BLoC builder gives us access to a very similar callback, but this one is called builder and must return a widget. Based on the state, we can show different widgets in our UI. If we analyze the callback, we can see that if the current state is a state where the user can make edits, we show the form for the user, otherwise we show a loading indicator. Let's dive deeper into the login states and login events. There are 5 states that describe the possible scenarios that can occur here: login initial, login in progress, login submitting, login done, and login failure. Then there are 3 events: email changed, password changed, and form submitted. Let's follow the entire flow of the login block. When the block is provided with the BLoC provider widget, the login block constructor runs where it calls the super constructor with an initial state. Here, we pass in our login initial as the state. Looking back at the UI code, in the BLoC builder, we can see that if the state is login initial, login in progress, or login failure, we show the user the form to enter their information. Now, when the user starts to enter their information, say their email address, an email changed event is added to the event stream. This kind of event is handled inside the login block. Inside the block, we have functions registered to handle each kind of event. When an email changed event is added to the event stream, this function runs, emitting a new state with the updated email and telling the UI to re-render. This event and state flow will happen when the user changes the email address or the password. Finally, when the user presses the form submitted button, the associated event is added to the event stream and is then handled by this function. Here, the information is validated and then passed to Firebase to attempt to log in. If the login is successful, the done state is emitted, or if the login is unsuccessful, we emit the failure state. As I stated before, events do not always need to be added based on a physical action from the user. Let's break down how the actual timer functionality works. Before even looking at the code for the block, we need a way for the timer to count down. This is done with this function that returns a stream. Every second, an int is yielded representing the time left. But this doesn't do anything unless we listen to it somewhere. So now we can look at the code for the block. Instead of walking through the entire block, I want to specifically focus on how a stream can be used to add events rather than physical interactions. Understanding this can set you apart in your mobile development journey as it applies to real-time updates if you want to use a tool like Firebase or other front-end framework. When a Pomodoro session is started, a stream subscription is created. We start listening to the stream that counts down every second. Each time a new value is emitted from the ticker stream, a Pomodoro ticked event is added to the event stream. Notice how the user did not have to do anything for this to happen. This event will happen every second, each time running the handler function where a new state is emitted with the current remaining duration. This will continue until the Pomodoro session has been complete. Now that we have an understanding of the block pattern, we can look at the second concept that you need to understand, which is Firestore. Similar to how we just went over the ticker stream subscription, the same thing can be done for Firestore to provide your app with real-time updates. If we look at the home block, in the constructor, a subscription is set to listen to the user collection. Anytime the user adds a task, an event is triggered, telling your app that something has changed and needs to be reloaded. So when we go through the create task flow and select to submit a task, our home UI automatically reloads, showing our user the task that they just created. This idea that a stream subscription can cause events to be added to the event stream can also be used when handling authentication with Firebase authentication. You can listen to the stream exposed via the Firebase Auth API, and when the stream returns a new user, you can navigate accordingly depending on if that user is authenticated or unauthenticated. This idea is how Taskmaster handles authentication. After the user selects to log in, an authentication stream is being listened to and the app automatically reroutes. I'll be creating an entire series on authentication, so if that is something that interests you, be sure to check those out in the future. So try out these tools and develop this app on your own. I hope you have enjoyed this video and learned something new. I'll see you all later.